Problems 1, 9, 19. So angle of elevation. So you'll hear both these terms. Everything comes off the horizon. Does that make sense? So when you do an angle of elevation or an angle of depression, everything comes off of the horizon first. Oh, that's not very flat, but off the horizon. So an angle of elevation has to elevate from the horizon. Does that make sense? It's the angle just coming up from the horizon. And the only reason that's kind of important is oftentimes you'll get a situation like this, where you've got something going on like that and like that. For angle of depression, the kids will pick the wrong angle. That would not be the angle you pick. It's always off the horizon, be that angle here. Or same thing if you have like a tree, angle of elevation, right, is here. And I've seen kids pick this angle here, right? But you don't do that, okay? Angle of elevation is always off the horizon up, okay? Got it? Seems pretty easy. So now let's do this problem. So a 6-foot man sights the angle of elevation to the top of a building to be 64 degrees. He's 100 feet away. How tall is the building? Now we've done this same problem maybe 3 or 4 times, right? So this should be pretty easy. So here's my building. Okay, here's my 6-foot man, right? And we want to make a right triangle. It's right triangle trig, so I'm going to go ahead and shoot the angle and make a right triangle out of it, okay? So always try and find your right triangle because this is right triangle trig. 100 feet away from the base of the building, 64 degrees, and we want to find the height of the building, okay? So set up your right triangle. The base is 100. Angle of elevation is 64 degrees, and the height of the building is what we want to find. Now, of course, the triangle suspended 6 feet up from the 6-foot man, so in the end, we'll add in the 6, right? You guys agree with that? Okay, so from the angle, always from the angle, that's my opposite side that I want to find. This is my adjacent side that I want to use. Opposite adjacent. I look up above, and it's tangent. So let's set up tangent of theta, but theta represents, the symbol theta represents angle. So I'll skip that step. We can just go tangent 64 degrees equals. According to my ratio, it's the opposite, which is x, over the adjacent, which is 100. And so I'm going to use my calculator, borrow Morgan's, okay? So I'll multiply up the 100, and I'll make it 100 times tangent of 64 is equal to x, and I'll just use my calculator. Now, one thing really important, you guys, if you start to get weird answers, check your mode. Every now and then, somebody messes up the calculators, but if you're in radian mode, you're going to get really bad answers. You have to be in degree mode because we're doing degrees, right? You can do all of the problems correctly and get all the problems wrong if you're in the wrong mode, okay? All right, now let's just do 100 tangent 64, and I get an answer of about 205, okay? 205, but we're going to remember to add in the 6 feet, okay, plus the 6, so 211 feet tall. Okay, thumbs up. Thumbs up, Landon. Far away. Okay, okay, thanks, Gwen. Okay. Angle of depression. Okay, angle of depression again comes off of the horizon. So you start with your horizon, and then the angle of depression is the angle that goes down. Okay? Pretty simple, but all of these have to be off the horizon. You either rise from the horizon or you go down from the horizon. Okay? So, an airplane 5,000 meters in the air begins a descent to the airport at an angle of depression of 10 degrees. How far is the plane from the airport? So let's draw a picture, okay? So my little airplane, right? Coming in for a landing. There we go. Let's put my airport way down here. Here's my airport tower. Okay. Airplane's coming on in, right? So we need a right triangle. So I'm going to go ahead and create my right triangle. here. And I know the airplane's 5,000 meters in the air, right? So the 5,000 is right there. That's how high it is right now. And it's descending. Now the angle of depression is here. The angle of depression is right there because we go down 10 degrees. Now, here's something. This 10 degrees is also equal to this 10 degrees here. These two are equal angles. Okay, and I don't know if you guys learned that already, but these two angles are equal. So I'm going to put the 10 degrees here because I like this triangle. You could also make another triangle up above it, which would work. But this makes more sense. See, this 10 degrees is equal to this 10 degrees here. Okay. Now, this is what I want to find. Okay. I want to find how far away the airplane is, right? So, I've got my opposite and my hypotenuse. So opposite hypotenuse is going to be sine. So I'll go sine of 10 degrees, because sine of the angle is equal to the opposite side, which is 5,000, over the hypotenuse, which is x. Okay. Now, when the variable's on the bottom, we got to make sure that we bring the x up, and then we'll bring the sine of 10 down. I'll do it in two steps. Bring the x up of x times the sine. That's a bad looking sign. Let me write that better. X, bring up the x. X times the sine of 10 equals 5,000. Okay, I brought the x up. Now I want to divide by sine of 10. And I'm just going to use my calculator to get the actual answer. So we'll go 5,000 divided by sine of 10. And I get about 28,793.9 meters. Sorry, it's in terms of meters. Okay, not too bad. So again, it all depends on finding that right triangle, right? If you find the right triangle, you're good to go. Okay, how am I doing?
Just fine.
Okay, turn the page. Okay, all right. Okay, so example 3. Find the area and perimeter of an isosceles triangle. Okay, so let's draw an isosceles triangle. Okay, vertex angle is 40 degrees, and the base is 12. Okay, now that's all I know. Well, what I want to do is find the area. So to find the area, I need to go 1/2 the base of the triangle times the height of the triangle. Okay, so the base is 12. We know that, but we don't know the height. So I can go at least area equals 1/2 12 times the height. I don't know the height yet, but I'm going to make a right triangle out of this. So the first thing I'm going to do is I'm just going to draw a line straight down the middle, and I'm going to create a right triangle. Okay, 90 degrees, and because it's an isosceles, I cut it right in half. Only because it's isosceles, I cut it in half. So this is now 20 degrees, and this side is 6, okay? Now, if I want to find the height, right, I need the height to find the area. I need the height. Opposite, adjacent, right? I'm going to use tangent. So I'm going to go, okay, tangent of 20 degrees is equal to the opposite over the adjacent. Opposite is 6, and the adjacent is h. Okay, again, I need to solve for h. The variable's on the bottom, so I'll bring it up, and then I'll divide, okay? So bring up the h of h. Tangent of 20 equals 6. I'll divide by tangent of 20. Divide by tangent of 20, and I'll just use my calculator. What is 6 divided by tangent of 20? I'll use my calculator. I'll find out in just a second. Tangent of 20, and I get an answer of about 16.5. And we're not done, but we're almost there. Okay, so if that's the height of the triangle, I just have to go 1/2 base times height. Okay, because I know the height now is 16.5. I'll put that right into my formula. So I'll go 0.5 times 12 times 16.5, and I get an area of about 99. And let's say centimeters squared because it's area. Okay, can you do one like that on Friday?
Yes.
Good. That's Friday. You're going to have a problem just like this on Friday, okay? That's not too bad, is it? Okay. All right, ready for 4? Last but not least, okay? Last but not least. So I want to find the area of this pentagon. It's pretty close to what we just did. It's very similar to the kind of problem we just did. However, inside this pentagon, we've got 1, 2, 3, 4, 5 triangles. You guys see all 5 triangles? So if I can just take a look at one of the 2 triangles. So what I'm going to do first is I'm just going to superimpose this one triangle, find the area of the one triangle, and then times that answer by 5. So let's do that. So first of all, let's superimpose this one triangle, okay? All right, I know that this is 10, and the angle. Find the angle. It's a full circle. Right, 360 divided by 5, right? Does that make sense? Thanks, Zoe. It is a full circle. And so it's divided by 5 parts, so I just go 360 divided by 5, and I get 72. So each of these angles are 72 degrees, right? 72, 72, 72, 72, and 72. Okay, so far so good. Now, let's go back to what we just did on the previous example. To find the area, 1/2 base times height. All right, I know the base. The base is 10. Okay, so I'm going to go area equals 1/2 10 times the height. Now, I don't know the height, but we're going to do the exact same type of problem we did prior to that, okay? So let's take a look at this triangle, and let's just cut it right down the middle. Shift it over here. What I really want to do is take a look at this triangle here, right? 95, because I cut the 10 in half, and 36 degrees. Half the 72, right? That's 72, half that's 36. So let's find the height of the triangle. Okay. Again, it's just like the prior example. I've got my opposite and my adjacent. Opposite, adjacent, I'm going to use tangent. So we're going to go, all right, I'm going to find the height by going tangent of 36 degrees is equal to the opposite, which is 5, over the adjacent, which is h. I'm going to switch places. I'm going to multiply it by h, bring it up, of h times the tangent of 36 equals 5. I'm going to divide by tangent of 36 and use my calculator to find out what that is. 5 divided by tangent of 36. And I get about 6.88, or how about 6.9? Okay, now I can finish this up. I put my 6.9 right up here. I'm going to go area equals 10 times 6.9. And I'm going to do one more thing. I'm going to times that answer by 5, because there's 5 triangles, right? This part will give me the triangle. I'll multiply that by 5, because there's 5 triangles, right? So I'm just going to use my calculator. I'm going to go, okay, 0.5 times 10 times 6.9 times 5, because of the 5 triangles. I get an answer of 172.5, and we'll say centimeters squared. What do you think? Could you do that one on Friday?
Yes.
Good. You might get the bonus point then.
Great.
That's an easy bonus, isn't it?
Yes.
I think so. Okay. All right. Let me go ahead and stop recording.